The current threat level from terrorism in the UK and many other countries is set to severe, and police and security forces acknowledge that their jobs are being made much, much harder because today's terrorists have at their disposal a range of social network tools. This helps them form alliances, attract new recruits, and orchestrate terror campaigns. But the associations that terrorists make through these channels can also help to identify them, if police are able to screen this sort of data routinely. Most people, though, are justifiably concerned about privacy. Now, Michael Cairns from the University of Pennsylvania has come up with a way to keep honest data safe, yet still enable security forces to track down the bad guys. As he explained to me, you just need to add some noise to the information.
One very natural use, of course, of social network data is what you might call crawling or searching, where you have an individual of interest and you look at who they've had contact with and take a harder look at those individuals to decide if they're part of whatever effort you're undertaking. And so really the picture is quite simple. You kind of have a network and you have one or more places as your starting points, and you're kind of crawling through the network in an incremental link-by-link way to try to find other individuals. And as you do this, of course, you'll encounter both the parties that you are looking for and also parties that you're not looking for. And the focus of our work is on trying to, on the one hand, effectively find the individuals that you're looking for while providing privacy promises to the people that you're not looking for.
How have you gone about doing this? How can you look after the people that want to retain their privacy?
At a high level, I think one virtue of what we've done is its simplicity and its intuitiveness. The way I like to describe it is if every week a company publishes an incredibly numerically accurate average salary for everybody in its organization, and between 1 week and the next week, the only thing that happens is one new person is hired, then even though you're publishing this aggregate figure every week, because you're doing it to numerical precision, it's possible to, back out exactly what the salary of the new employee is. But if you add some noise to it, you don't publish it to 10 decimal places, you publish it only to 2 decimal places, for instance, and you have 10,000 employees, then it turns out you can't really infer anything about any individual's salary. And so we're kind of doing the same thing in the setting of social network search. By adding randomization to the search process, we are able to provide guarantees that mean that the people that are not the focus of your search won't have their kind of link or network data compromised too much.
You're kind of making the data a little bit more murky, a bit less easy to see through. But can you still find these people in the first place?
That's right. So, it's important to make a distinction between the internal operation of the algorithm and what the algorithm might be able to see or know, and what the output of the algorithm is and what inferences can be made from that.
So by using a kind of a blind machine, purely a mathematical formula, you can input that and the machine can do all the work, but their information can stay hidden.
That's right.
There's always a lot of talk about how much of our data is private, how much is being used, and I think there's very little clarity there. Do you have any idea of what's happening right now, and are we potentially being exposed?
The people doing the technical work and, let's say, building models, it's not like they're unaware of concerns like privacy or fairness or regulatory issues, but there was always sort of some other group in the organization that kind of worried about that. And I think more and more we're going to see efforts to try to provide algorithms that themselves have some of these guarantees built into them.
I think security is somewhere where people might be a little more willing to give away a little bit of their privacy, but more and more with big data and with all this data we're collecting, we're seeing many different areas where we could be using it a lot. Through algorithms like yours with built-in security there, will we be able to use maybe much more of the data that's available to us?
The technical answer to it is yes, right? I mean, if you use algorithms as like the ones we're suggesting, there are some privacy guarantees, and so in principle, people should feel more comfortable about their data being used by such algorithms versus an algorithm with no privacy guarantees whatsoever. I think it's important to remember, though, that, it's one thing for us to propose an algorithm that has some mathematical guarantees of this kind. It's another thing for organizations to actually use such algorithms. And it's yet a third thing for people to trust them.